Welcome to Eyjafjallajokull of the East Volcanic Zone. Located in beautiful Iceland, this stratovolcano rests upon a divergent boundary between the North American and Eurasian plate. Let's head up. God, what a great view. Whoa, watch your step. This region's been really active lately, and plenty of earthquakes have torn open small faults in the surrounding area. Alright, let's head further up the trail. Hey, that's a trail marker. Why don't you give it a read? March 20th, 2010. The Institute of Earth Sciences reports an eruption late at night. The next day, 15 lava fountains are found spurting from a fissure up to 185 meters into the air. Flights are cancelled, roads are closed. 500 people living nearby are evacuated. The eruption lasts an entire day, with lava flowing into nearby canyons. On the 31st, more fissures form, sending more lava careening into the air and down into surrounding gullies. Police report that nearly 25,000 people visit the site, and there are only 2 casualties, both due to the strenuous hike. The lava covered an area of about 1.3 square kilometers with an average of 15 meters thick. Alright, let's head a bit further up the mountain. This trail is the most popular. I can see why, it's quite beautiful. But it's really a tough hike. Luckily, the air from the glacier makes this actually quite easy. Glaciers are actually slow-moving masses of ice that slowly grind up the ground beneath them. The ground here is actually made out of mostly basalt and andesite thanks to the volcano. Alright, looks like we've reached the spot where you can see both plate boundaries. This is a divergent plate boundary, so this is where they both split off and move away from each other. This out here is the Eurasian plate, and on the other side is the North American plate. Look at that view. Alright, looks like there's a trail marker over here. Go take a look. April 13th, seismic swarms form a new vent in the caldera under the glacier. Early the next day, an 8-kilometer high plume of ash erupts from the vent. Meltwater rushes down the north and south of the summit. 700 people have to be evacuated as flooding and lahars destroy property. Roads are gone, farmland ruined, but no casualties are reported. By April 15th, the ash plume reaches Europe, completely shutting down almost every major airline. The eruption continues with varying intensity for 39 days as new earthquakes, explosions, lahars, and craters are formed. Airlines in Iceland and Europe lose an estimated £130 million every day due to closings and cancellations to avoid the ash clouds. Thousands of people are left stranded in foreign countries as closings fluctuate throughout Lake June. Alright, let's head up towards the caldera. This is a stratovolcano, which means its sides are composed of cooled magma, igneous rock, and it can be very steep. Watch where you step. Some of these rocks are really hot, and try not to breathe in any of the gas. Alright, we've nearly made it to the top. We're now at the summit. Just a few yards ahead is the crater. That's a trail marker that we'll get to later. But right now, we're going to take a look at this lahar over here. Follow me. As the volcano becomes more active, the water melts from the glacier, mixing with mud and rock to form mudslides or lahars if they contain volcanic rock. These were the major danger of this volcanic eruption in the past, and hopefully nothing like this ever happens again. Why don't we go take a look at that trail marker? The main hazard the eruption posed was the persistent ash clouds and the distance that they went. They wreaked havoc for airlines for nearly 2 months. Upon analysis later, it was found that the ejected ash contained long, jagged particles that allow it to stay aloft for a long period. This facilitated further travel of the cloud across vast distances and helped it to remain airborne for as long as it did. Since the eruption, research in satellite imaging and drone technology have given more insight into the event, but more advances are needed to understand and prepare for events like this in the future. Alright, let's head up to the crater. I've brought some protective gear for you, because it's going to get really hot. Alright, let's go. Don't fall, I'm not saving you. Alright, welcome to the top. Well, this is where all the main magma is. Magma wells up from the divergent plate boundary below and makes its way to the surface, where it spills out over the sides of the volcano. As it cools, this slowly builds the volcano higher and higher, until eventually an eruption will knock it down. Speaking of eruptions, did you know that a high silica content can cause an eruption? You know, they trap rocks together in the lava, which makes it sticky. And gases can build up, and then they are violently released. Hey, is that lava looking really thick to anyone else? Oh my. Run!